Hello, my name is Adrian, and I'm an engineer here at Keysight Technologies. In this video, we will be looking at a wireless LAN signal using 802.11a standard to demonstrate basic digital demodulation techniques. When troubleshooting, there are three key analysis techniques that when put together form a troubleshooting process as observed in this diagram. In this video, we will be looking at what typically is the first stop in this process, basic digital demodulation. First, let's set up the measurement. Set the input range. This is very important and should be the first step in setting up a measurement. This can be done through input, analog, range, or by double-clicking on the range above the trace. It is important to have the appropriate input range. If it's too low, it may overload the hardware's ADC, and if it's too high, it increases noise. We will set it to just above from where we get an overload message. To set other settings, we can use preset to standard, where the VSA software will preset settings to their default values for the particular standard, in this case 802.11a. To do this, go to Measurement Setup, Demod Properties, Format, Preset Standard, IEEE 802.11a. This will preset span, guard interval, subcarrier spacing, and more. This information and the specific default preset values can be found in the help text. If specific customization is wanted, one can also change any of the values changed by the preset manually. Let's begin examining the traces by looking at the symbols and errors table. This, along with all the other options that we will explore today, can be selected from the drop-down menu on a trace. This table provides key metrics that indicate the quality of the signal. The main metric to pay attention to is error vector magnitude, EVM, which comes from the difference between the measured signal and a calculated reference signal. IQ measurement plots the measured IQ symbol values of the subcarriers. The data of this trace can be displayed in different formats, the most popular of which is constellation. This displays the data and pilot subcarriers in different colors. As an example, we can also display the log magnitude of the same data, which shows a plot over a number of carriers, where the red dots are the actual measured data points. If EVM and constellation don't look good, we can have a look at other options to gain further insight. A good measurement to look at is search time. It is important to know that there must be at least one full burst or it displays pulse not found and therefore can't be demodulated. If we make the search time long enough, there will always be a full burst in the search time as seen in this trace. We can set up the trace for time, which will display the first full burst in the search time. This is the data before it gets sent into the demodulator. We can then do further analysis on it, such as perform an FFT, which is what is displayed in this spectrum trace. Other important traces to look at are EV spectrum and EV time. These help us understand where the EVM came from. These plots display the error at many different points, and the average of these is the EVM that we see in the error table. These show the error plotted for every subcarrier and every symbol being measured. Both of these show the same data, but plotted on different axes, which can help to observe different trends. EV spectrum shows the error with respect to frequency, and EV time displays it with respect to time. During the preamble, an equalizer is created and applied to correct for frequency response error. It is possible to view the output of this equalizer by changing the trace to channel frequency response. This shows what the channel looks like and what we had to correct for. We have now seen a variety of key options in the demodulator and what they are useful for. Thank you for joining us in an overview of basic digital demodulation in VSA software. For more information on any of the topics mentioned in this video, please consult the VSA software help files.